Okay, so in this video we are going to attempt mock paper B, mock exam B. So first question is, to two decimal places, what is the molar mass of ammonium sulfate? So nitrogen is having 14.01 and then hydrogen is having 1.008, sulfur is having 32.06, oxygen is 16. So putting the value in the formula, nitrogen is 14.01 plus 4 times 1.008 for hydrogen, times it by 2 here, and for sulfur is 32.06. For oxygen you are going to multiply 16 with 4. You are going to multiply 16 with 4, and the final answer that comes out to be is 132.14. The answer is B. For second question, they are saying a charged particle has the electronic configuration argon 3d3. What is the identity of the particle? For chromium, the number of electrons are 24, and when it loses one electrons it becomes 23. Okay, and if we are going to write the electronic configuration of chromium, then we need to see one thing here which is very important. For the electronic configuration of chromium, it is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d4. But there is an exception in the case of chromium and copper. The electron which are present in 4s2 will be transferred to 3d4, and because of this the electronic configuration for chromium becomes 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Now, what happens when one electron has been removed from chromium? Then what happens when one electron has been removed from chromium? Then you are going to see one electron will be removed from 3d6, then it would become 3d5. So now for vanadium. Vanadium is having 23 electrons, and when it loses 3 electrons, then it becomes 20. And now let me write the electronic configuration for vanadium first. When it is having 23 electrons, so it is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d3. And when it tries to lose 3 electrons, so first the electron will be removed from outermost shell, that is 4s2. So 2 electrons will be removed from this one, and then 1 electron will be removed from this part. So then what happens? Its electronic configuration finally becomes 1s2, 2s2, 2p6, 3s2, 3p6, and after losing electron, first the 4s2, 2 electrons will be removed, and when 1 electron is removed from 3d3, so it would become 3d2. Now for the next titanium, it is having 22 electrons, and when it loses 2 electrons it becomes 20. It is having electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d2. And when it tries to lose 2 electrons from there, then 2 electrons need to be removed from this part. So this one would become 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d2. And for vanadium V plus 2, it is having 23 electrons minus 2. This one would become 21. So this its electronic configuration is basically 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. and when it tries to lose two electrons will be removed from this part, and this one would become 1s2, 2s2, 2p6, 3s2, 3p6, 3d3. So if you see, this part is having how many electrons? 2 plus 2 4 8, 2 plus 2 4 plus 6 10 12 18. So that is basically argon, and the other part is 3d3. So our right option is going to be D. For the next part, they are saying the chemical formula of the fertilizer ammonium nitrate is NH4NO3. What is the mass of nitrogen in 23.15 gram sample of ammonium nitrate? So first of all, you need to see nitrogen. How many nitrogens are there? There are two nitrogens. So you need to multiply 2 with the nitrogen molar mass 14.01, and at bottom you are going to write the total molar mass of ammonium nitrate. First we can write for nitrogen 2 times 14.01, and then for hydrogen, that there are 4 hydrogen, 4 times 1.008, plus for oxygen it's going to be 16.01, and times it with 3, and then you are going to have to multiply that with the mass of ammonium nitrate that has been given to you, that is 23.15, and the final answer that you will get, that is going to be 8.10 grams, and that is going to be C. Now, for the next question, they are saying, what is the average atomic mass of iron? You are given with the isotopes and their percentage abundance. So first of all, let's do it, how we are going to do it. Like, first of all, we have isotope 54, Fe54. You are going to multiply its percentage abundance, which is 5.845, times with the isotopic mass, that is 53.9396, plus you are going to do 91.754 times with the isotopic mass, which is this one, that is 55.9349. Then you are going to multiply the percentage abundance of 57, which is 2.119, times with 56.9354, plus you are going to do 0.282 times with 57.933, and divide them with 100. So the final answer that you will get here is 55.845, and the answer is going to be D. So for the next question, which of the following electron configuration present the element with the highest electronegativity? So these are having how many electrons? 2 plus 2 plus 3 is 7. So that is going to be nitrogen. 2 plus 2 plus 4, that is 8. So that is oxygen. And then we have 4 plus 6, 10 and 12. So we are going to have, this is going to be 8 plus, yes, so that's going to be magnesium. And then we have 4 plus 6 is 10, and 10 plus 3, that is 13. So it's going to be aluminium. So we have these elements, and they are asking which is going to have the highest electronegativity. So for electronegativity, you need to remember one thing, that for electronegativity, that basically increase across the period, because of increase in nuclear charge, and because of the same shielding and decrease in atomic radius. So it increase across the period, and also it decrease across group. So you need to see that oxygen is the element which is present at the most right, okay, and at top, most right and top, okay. So you are going to say that oxygen is going to be the most electronegative element. Which of the following condition must be true for substitutional alloy to form? So for substitutional alloy, you need to remember one thing here, that for substitutional alloy, they are going to have the similar, almost similar atomic radii, and when they are mixed together, they do not distort or disturb the lattice structure. The lattice structure remains the same, okay. But for interstitial alloy, uh, because of the difference in atomic radii, they are going to distort the lattice structure. So which answer is going to be the right one? That is going to be C, that the two metals are going to have the similar atomic radii and chemical properties as well, okay. They must need to have the same chemical properties as well. Moving towards the next question, they are saying 6 gram of calcium carbonate decomposed to form 2.73 gram of calcium oxide according to following equation. What is the percentage yield of calcium oxide? Now you can see the yield that has been given to you, that is going to be actual yield. So actual yield is the one that is always given in the question. That is always given in the question. So formula to find out the percentage yield is basically actual yield divided by theoretical yield times it with 100. Theoretical yield you are always going to find from the equation. So you are given with the mass of calcium carbonate. So first you need to find the mole of calcium carbonate, that is mass 6 grams, and divide with the molar mass of calcium carbonate, that is 100.09, and this comes out to be 0.05995, and from that you are going to find the moles of calcium oxide. You know calcium carbonate is here, calcium oxide is here. We are going to use the ratio method. From the equation they are 1:1, so I'm going to put 1 here, I'm going to put 1 here as well, 0.05995, and that is also 0.05995. So now you are going to find the mass of calcium oxide, which is the theoretical yield. That comes out to be moles is 0.05995, times it with the mr. Mr is 56.08 for calcium oxide, and it comes out to be 3.362 grams. Actual yield is how much there? Actual yield is, that has been given to you, that is 2.73. Theoretical yield you have find from the equation 3.362, times it with 100. So the final answer that comes out to be is 81.21%. So that is going to be B. So next question, in which of the following pair is the first element expected to have higher electronegativity than the second one? So if you see option B is magnesium, where they are present in group 2, and magnesium is present in group 2 up as compared to strontium. Strontium is present down the group. Magnesium is present up the group, and we know about electronegativity, that for electronegativity that basically decrease down the group, and that increase across a period, So what happens because of that? When it decrease down the group and increase across the period, so magnesium is going to have the higher electronegativity as compared to strontium, which is going to have the lower electronegativity. So the answer is going to be B. For the next question, they are saying what is the formal charge on atom 1 in the hydrogen phosphate ion. So if you want to find the formal charge on it, formal charge has a formula. Formal charge is equal to valence electron minus 1 by 2 number of bonding electrons minus you are going to have number of non-bonding electrons. So this is a formula. So if we see oxygen here, oxygen is having how many electrons in its valence shell? It belongs from group 6. So it is having 6 electrons in its valence shell minus 1 by 2 number of bonding electrons. It is making a single bond with this hydrogen, because if this is hydrogen, let's say this is oxygen and there is a phosphate over there. So oxygen needs to complete how many electrons in its outermost shell? 8 electrons. It is having 6 electrons already. It makes a single bond with this hydrogen, and with this phosphorus it is also making a single bond. So bonding electrons are going to be 4 there, and the non-bonding electrons for oxygen, as it is having 6 electrons in it total, one is here, one is there, 2, then 2 electrons will come here and 2 electrons will come here, so they would become 4. So this is going to be 6 minus 2 minus 4, and that is going to be 0. So the answer is going to be A. So for the next question, question number 10, what is the formal charge on atom 2 in hydrogen phosphate? Phosphorus is the second atom. So now we are going to use the same formula that we have used before, and the formula was the formula which we are going to use here for phosphorus. Phosphorus belongs from group 5, so it is having 5 electrons minus 1 by 2. What are the bonding electrons for phosphorus? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 electrons that are present there, minus number of non-bonding electrons. So there is no non-bonding electron which is present on phosphorus, so you are getting 0 there. So 5 minus 5 minus 0, the answer comes out to be 0. So the next question, what is the formal charge on atom 3 in hydrogen phosphate ion? So we have to find out the formal charge on this. The formula will be the same, so I'm going to copy the formula. That is going to be formal charge minus 1 by 2 number of bonding electrons minus number of non-bonding electrons. So I'm going to put it over here. Now valence electrons are how many? For this oxygen we know it's going to be 6 because it belongs from group 6. Now number of bonding electrons, 1, 2, so that is going to be 2, minus number of non-bonding electrons. Non-bonding electrons, that needs to be like 1, 2, as it has gained electrons. So 1 here, 2, 1, 2. So 6 electrons will come here, because although it is going to be 5, as oxygen has total 6 electrons, but you know one thing, like it is going has gained one electron, so although it has bonded one electron there, but in total it is going to have 6 electrons. So because it has gained one, there is a minus charge at the top. So 6 minus 1 minus 6, that comes out to be minus 1. So the answer is going to be B. For the next question, a 5.323 gram sample of anhydrous potassium sulfate is dissolved in 1.75 liter of solution. What is the molarity of solution to 3 significant figure? So first of all, you need to find the mole of potassium sulfate, and that is equal to mass over molar mass. Mass is 5.23 divided by molar mass, that is 174.3, and the answer comes out to be 0.030. And if you are going to find the molarity there, molarity is mole per unit volume, mole per unit volume. So mole is how much? 0.030, and volume is going to be 1.75, and the answer that comes out to be 0.0171. It is going to be B. So for question number 13, which of the following statement about silicon dioxide is correct? Silicon dioxide is a covalent network solid. So first of all, one thing here, that silicon dioxide, which is SiO2, has a giant covalent structure similar to diamond, similar to graphite, and it is going to have what happens in its structure, like each silicon is surrounded by 4 oxygen atom, and each oxygen is surrounded by 2 silicon atom. So option 1 is correct. Silicon dioxide is a covalent network solid, and option 2 is also correct, that each silicon atom is covalently bonded to 4 oxygen atom, and each oxygen is surrounded by 2 silicon atoms. So this is also correct. While it is not a conductor of electricity, why? Because it doesn't have any free moving electrons. So option 1 and 2 are going to be right one. So for the next question, they are saying if the frequency of a photon of electromagnetic radiation is 5.0 times 10 to the power 14, so that means frequency is V is equal to 5.0 times 10 to the power 14, and they want me to find the energy of the photon. The formula is HV. H is the Planck's constant, which has a value 6.6 times 10 to the power minus 34 times with frequency 5 times 10 to the power 14. Then the value of E, that comes out to be, after multiplying them, 3.313 times 10 to the power minus 19 joules. So our answer is going to be C. For the next question, they are saying what is the conjugate acid in the reaction above. So conjugate acid, first of all, this is going to be an acid because it donates a proton to this one, and that is going to be a base. So when an acid donates a proton, then it becomes a conjugate base. So this is going to be a conjugate base. When an acid donate, no, this is a conjugate base. Sorry, this is a conjugate base because when it donates a proton, so it becomes HPO4, so that is a conjugate base. And when a base accepts a proton, it becomes a conjugate acid, so that is going to be a conjugate acid. So our answer is going to be HCN. So for the next question, they are saying the rate reaction for the reaction between iodine and propanol is determined to be rate is equal to K times concentration of hydrogen ion times propanol. Which graph is consistent with this information? And they have plotted a graph of rate of reaction with the concentration of propanol. So first of all, if we see the rate equation at the top of propanol, there is nothing written there. So if there is nothing written there, that means the reaction with respect to propanol is first order. That is first order. And if the reaction is first order, that means that rate is directly proportional to concentration, and we are going to have the straight line if we are plotting the graph of rate of reaction versus the concentration. So straight line is basically given by the option C, as it is first order. So for 17th question, they are saying we have one pentane and we have an isomer of pentane, which is 2,2-dimethyl propane. Which isomer of pentane shown above has the highest boiling point and why? So pentane is having a less compact structure, and it is having more compact structure. And you are going to see one thing, because of less compact structure, C, they are going to have like more contact points with the pentane, and they are having less compact points when we have dimethyl propanol. So less contact point means less contact points, and it is having more contact points and it is having less contact points. So because of more contact points, it is going to have stronger intermolecular force because of more contact points, and it is going to have less intermolecular force. And we can see one thing here, that because of stronger intermolecular force, pentane is going to be having the highest boiling point. So option B, what it is saying, pentane, because it is less compact than 2,2-dimethyl propane. Question number 18. Now they are saying that which is, they have given us the reaction mechanism, and they are saying which of them is intermediate, catalyst, and the reactant. So first of all, let's see this CH3COCH3, which is present in the in the main equation, that is going to be the reactant. And this hydrogen ion that you are adding here, that is also regenerated at the end. So this is going to be the definition of the catalyst, because catalyst is not consumed in the reaction, it eventually regenerated. Okay, so H positive is going to be the catalyst, that is shown by the equation, that reactant is CH3COCH3, that is shown by these options, and catalyst has only been shown by C option. And intermediate, what is intermediate? Intermediate is going to be the thing that is formed in the reaction and is also consumed in the reaction. So intermediate is a species that is formed during the reaction and is also consumed during the reaction. So if you see this option like CH3COH, that is basically generated in the reaction, and that is also consumed in the reaction as well. So that is the definition of intermediate. So option C is going to be the right one. So for question number 19, they are saying calcium nitrate reacts with potassium sulfate and form calcium sulfate precipitates. These are precipitates that are formed. The value of Ksp has been given to us, and now they are saying when you are trying to mix both solution, which of the following will be observed. So first of all, we have a formula: concentration is equal to mole per unit volume. So if you are mixing them, you can see that volume becomes doubled, because when you are mixing 100 ml with 100 ml, then volume becomes doubled. Okay, and when volume becomes doubled, then concentration needs to be half. Okay, so if we see like the concentration of calcium ion from calcium nitrate, so calcium ion concentration from calcium nitrate, you need to do 1.70 times 10 to the power minus 3 divided by 2. Why we are doing 2? Because volume is doubled, so concentration becomes half. And for sulfate ions, what we need to do, like when the concentration its concentration also become half, and that is coming from potassium sulfate minus 3 divided by 2. This comes out to be 8.5 times 10 to the power minus 4, and this comes out to be 7.50 times 10 to the power minus 4. And when we are going to have the formula for Q is equal to, as you know, calcium sulfate in a reversible reaction would form calcium plus 2 aqueous plus sulfate aqueous, and Q is equal to the product of calcium ions and the sulfate ions. So the formula is going to be 8.50 times 10 to the power minus 4 times 7.5 times 10 to the power minus 4, and the answer comes out to be 6.38 times 10 to the power minus 7 molar. And if you compare the value of Q and Ksp, you are going to see that Q is less than Ksp. If Q is less than Ksp, then what happens? The reaction would shift towards right hand side, and you can see that no precipitate will forms. And when no precipitate forms, so the answer is going to be D, that no precipitate forms because Q is smaller than Ksp. So moving to the next question, question number 20. A sealed 6-liter cylinder contains 13.30 gram of carbon dioxide and 17.00 gram of argon. What is the total pressure? So for total pressure, first you need to find the total moles. First we are going to find the moles of carbon dioxide, and that is going to be equal to mass by molar mass. Molar mass of carbon dioxide is 44.01. That comes out to be 0.30 mole, and for mole of argon it is going to be 17 by 39.95, which is the molar mass of argon, and the answer comes out to be 0.43 moles. So total mole is equal to 0.3 plus 0.43, and the answer comes out to be 0.73 moles. P is equal to, when we are going to find the total pressure, so nRT divided by V. N is 0.73, R is 0.08, 206. T is the temperature, which is 303, and volume is going to be volume is 6 liter, so pressure comes out to be 3.03. So answer is going to be C. For question number 21, they have shown us the titration curve, and they are saying which is going to be strong acid, or like which acid is there and which base is there. So you can see this place is very high, so that means it should be around 14, so that means it is going to be a strong base. And the graph is ending close to pH 7, that means it is going to be a weak base. So the answer is going to be D. No, answer yes. Oh, sorry, that is a weak acid. So next question, question number 22. What is the primary reason why lipids are insoluble in water? Lipids are basically fats and oils, and if you see their structure, then you are going to see that they are primarily non-polar molecules. Non-polar they are non-polar molecules which actually does not form hydrogen bonding with water. So if they does not form hydrogen bonding with water, because you know water is a polar molecule, so you can choose the option B, that lipids are non-polar and do not form hydrogen bond with water molecules. Moving towards the next question, they are saying 2HI, they are forming H2 plus I2. Kp value is 83 at 723. A mixture of HI, H2 and I2 is placed in a sealed rigid container. After equilibrium is established, the pressure inside the container is halved. So pressure is halved there, this is important, while the temperature is held constant at 723 Kelvin. Which of the following will most likely to occur? You can see here that 2 moles are forming 2 moles. So volume is not changing. So if you are changing pressure, the equilibrium will not change, equilibrium will not shift, as the number of moles are same on both sides. So equilibrium will not shift. Equilibrium will not shift if pressure is changed. So if equilibrium is not changing, the number of moles will also not be changing, and the partial pressure of HI or H2 or I2 will remain constant. So option A is going to be the right one. Which of the following statement correctly describe the energy changes associated with bond breaking and bond formation? So first of all, we must know one thing, that bond breaking is an endothermic process, and in which energy absorbed, and bond formation is going to be exothermic, in which energy release. So which option is going to be the right one? It is going to be B, which is bond breaking is an endothermic process and bond formation is an exothermic process. So adding which of the following to a 50 milliliter sample of 0.1 molar CH3COH would result in the formation of buffer solution with a pH of 4.76. So the formula is pH is equal to pKa plus log of concentration of salt divided by acid. And they want pH to be equal to pKa value, which is 4.76. For that purpose, this must need to be 0. And how it becomes 0? When the concentration of salt and acid becomes equal, then log of 1 becomes 0. So we need to see where the salt and acid concentration they becomes 0. First of all, mole of CH3COH is 0.1, which is the concentration times with the volume, that is 0.005. We have to convert it into liter. That is 0.05. That is 0.05. So it comes out to be 0.005. And now one thing here that is going to be, we need to do what? We need to halve the concentration of in order to find for NaOH we need to halve the moles of CH3COOH, and for the mole of NaOH that is going to be 0.005 divided by 2, that is 0.0025. So volume of NaOH needed would be, volume of NaOH needed is going to be 0.0025 divided by 0.1, and that comes out to be 0.025 liter, that is 25 milliliter. So 25 milliliter is going to be D part. Only in that condition you are going to have equal moles of CH3COH and the salt, which is CH3COO minus, because when they react they are going to form this salt. So this also need to have the concentration of 0.0025, and when they both are going to have the equal concentration, the salt and acid, only in that condition pH value becomes equal to pKa. So for the next question, in an electrolytic cell used to electrolyze molten NaCl, what happens at the cathode? In molten NaCl we have Na positive and chloride ion negative. Because it is not aqueous, so we will not be having the water. So at cathode reduction take place, and at anode oxidation take place. So cathode, what is going to happen? The cations always travel to cathode. So cation is Na positive, so it will travel to cathode. Na positive will be gaining 1 electron and would be forming Na solid, while anode A9 travels and would be forming 2Cl minus, and it would be forming Cl2 plus 2 electrons. So what gets deposited at cathode? That is sodium ions, and reduction of sodium ions taken place there. So for the next question, the reaction they have given is N2 plus 3H2. They are forming 2NH3. So what happens here? They are going to reverse the reaction and also multiplying it with 2. So when they are going to reverse the reaction, then this is the value of Kc, and when they reverse the reaction, then Kc comes into denominator, 1 by Kc, and this whole equation is also multiplied with 2 after reversing it. So you need to make it as a square So it comes out to be 1 by 2.7 times 10 to the power 3 whole square, and the answer comes out to be is 1.37 times 10 to the power minus 7. So our answer is C. So for the next question, they are saying question number 28. A mixture contains 4 solids at room temperature. Substance P, a non-polar molecular solid with low melting and negligible conductivity. Substance Q, a covalent network solid composed of carbon in a 3D lattice with a very high melting point and no electrical conductivity. And then ionic solid, which is composed of small similarly charged ions with a high melting point and conductive when molten. A metallic solid with high electrical conductivity, malleability, and an intermediate melting point compared to Q and R. So which is going to be the strongest force among them? So strongest is going to be the Q, that is comes at one part, and then we have ionic bond, which is considered to be the second one. Then it is going to be the metallic solid, that comes out to be the third one, and the weakest is going to be the non-polar molecular solid, which is going to have the low melting point. So they are saying in what order would the substance transition to liquid or gaseous phase and why? So option A is going to be the right one, which suggests us that the weakest is P, then we have S, then we have R, then we have Q, because of the increasing strength of intermolecular intrinsic bonding from molecular to metallic to ionic to covalent network. Covalent network, which is giant covalent structure, that is going to have the strongest force of attraction, and it is going to have strongest covalent bond and having highest melting and boiling point. Moving towards the next question, they are saying which of the following is a key characteristic of a chemical change. For a chemical change, a new substance forms, and that is going to have different chemical properties. So the answer is going to be A. For the next question, which of the following reaction would show an increase in entropy? So we have 3 different reactions in which zinc solid is reacting with nitric acid and is forming zinc nitrate plus hydrogen gas. So this is in solid, aqueous, and is forming gas state. So this is having increased entropy because from solid and aqueous form you are forming gas towards more disordered state. So first one represents increase in entropy. For the second one is calcium carbonate in solid state is forming calcium oxide in solid state plus carbon dioxide in gas state. So you are going from solid to gas state. So what happens, like you can see one thing, that you are going from solid to gas state, so you are moving from less disorderness to more disorderness. So it is going to be increase in entropy as well. And the last one is combustion of methane. For combustion of methane, we have this equation. You are forming CO2 in gas state plus 2H2O in gas state. So you are forming from 3 moles, you are forming 3 moles of gas as well. So there is no increase in entropy. So increase in entropy is only taking place in 1 and 2. So answer is going to be B. For the next question, they are saying a student creates a calibration curve of relative absorbance of a fixed wavelength of light for different concentration of nickel 2 ions. In a further experiment, they want to use the calibration curve to determine the number of moles of nickel 2 sulfate in 150 milliliter sample of solution of nickel 2 sulfate of unknown concentration. The unknown solution is measured and found to have relative absorbance of 0.6, and now they want us to find the moles, and we are given with the volume. So if we see this curve, the relative absorbance is 0.6, and if we are going to plot a graph here, so the moles that comes out to be is around 0.66. If they are 0.66 and we have a formula which is going to be equal to mole is equal to concentration times volume. So concentration is how much there? Concentration is we have seen it's going to be 0.66 times it with the volume, that comes out to be 150 milliliter, and we have to divide it by 1000 to convert it into liter. So that comes out to be 0.099. So our answer is going to be A. For the next question, they are saying the Kb value of a base is given. What is the pKa value for the conjugate acid at this temperature? In order to find out pKb from Kb, we have a formula pKb is equal to negative log of Kb. Negative log of Kb is going to be 8.0 times 10 to the power minus 4, and value of pKb that comes out to be is 3.1. Now we have a formula pKw is equal to pKa plus pKb. pKw is 14, pKa we need to find out, and pKb is 3.1. So pKa value that comes out to be 14 minus 3.1, and that is going to be 10.9. So pKa value comes out to be D. For the next question, they are saying a rate law is found to be rate is equal to Ka square times B. As there is a 2 at the top, so that means rate of reaction with respect to A is going to be second order, and with respect to B is going to be first order. Now they are saying which of the following changes will not alter the initial rate of reaction. So if you see option D, which is saying halving the concentration of A. So if you are doing the half the concentration of A, so that becomes 1/2. And we know for second order, if you increase, like if you half the concentration of A, then rate becomes double. So rate becomes double, so it becomes 1/2 square. So the rate with respect to A is going to become double. As you half the concentration, it becomes double, so it comes out to be 1/4. So rate of reaction with respect to A comes out to be 1/4. And when you see for B, they are saying quadrupling the concentration of B, means you are increasing the concentration of B by 4 times. That becomes 4. So if it is first order, then if you are increasing the concentration by 4 times, rate also increase by 4 times. So if you multiplying 1/4 times 4, it becomes 1. So we don't have any increase in the rate if the concentration of A becomes half. Okay, because when it becomes half, then rate becomes double. So rate becomes 1/4, and quadrupling the concentration of B means you are increasing it 4 times. So 1/4 times 4, it becomes 1. So the answer is going to be D. What is meant by thermal equilibrium? So for thermal equilibrium, we need to see the characteristics of thermal equilibrium. That means like two bodies are in contact, and they no longer exchange heat. So if they don't exchange heat at this time, so that means that their temperature remains the same. And if temperature remains same there, then that means kinetic energy also remains same, because kinetic energy is directly proportional to temperature, so kinetic energy also remain same. So the option is basically C. Two bodies have the same kinetic energy, so their temperature is same. Answer is C. So for the next question, question number 35, they are saying we have four identical 300 milliliter cups of freshly brewed coffee that was originally at 91 degrees Celsius, and that was stirred with different spoon as listed above. In which cup will the temperature of the coffee will be highest at thermal equilibrium? So we are given with the specific heat capacity of spoon, mass of spoon, and initial temperature of spoon. So we need to find out its Q, the value of Q of each one of them, and for that delta T is final temperature, which is 91, minus initial temperature of spoon, which is 20. So I'm going to subtract them, and the answer comes out to be 71. Now we need to find out the value of Q, and the formula is MC delta T for each one of them. And one more important thing, the smallest value of Q of spoon will give us the value of the coffee in that cup, which is going to be at the maximum temperature. That means that spoon has got the least heat from the coffee. So we need to find out the spoon with the smallest value of Q that has gained that has gained that has gained least heat from coffee, and that maintain temperature of coffee at highest temperature. So we need to find out the smallest value of Q. So I'm going to apply the formula on each one of them. That is 7.0 times M is the mass, C is the specific heat capacity, 0.9 times delta T is 71. So I'm doing it for each one of them, and let's see which is going to be the right answer. So the least value of Q is for option D, and for the small value of heat of spoon, that means it has gained less heat from the coffee, keeping the coffee at highest thermal equilibrium. So answer is going to be D. For the next question, they are saying 0.96 gram of hydrogen gas is contained in a sealed container of volume 7.0 liter at a temperature of 303 Kelvin. So first I'm going to find the mole of H2, that is mass, which is 0.96 divided by molar mass, which is going to be 2.016, and that comes out to be 0.476. Finding pressure nRT divided by V. N is 0.476, R is 0.08206 times with 303, which is temperature, and volume comes out to be 7 liter, so it comes out to be 1.69 atm. So our answer is B. For the next question, they are saying in an electrolytic cell, a current of 2.5 ampere is passed through a solution of copper sulfate for 30 minutes. How many grams of copper will be deposited at the cathode? First, it is going to be a solution of copper sulfate. That means copper sulfate is going to be equal to, that is forming copper plus 2 ions plus sulfate ions. So at cathode, what is going to happen at cathode? It is going to gain copper plus 2 electrons, and that would be forming copper solid. So first of all, I am going to calculate the charge. Charge is Q is equal to current time multiplied by time. Current is 2.5, and for time we have 30 minutes. We have to convert it into seconds. So it comes out to be 4500 coulomb. So for 1 mole of electron, the charge is going to be, for 1 mole of electron, the charge is going to be 96,485, which is Faraday's constant, coulomb per mole. And but we are gaining 2 electrons. Copper plus 2 is gaining 2 electrons. So for 2 mole of electrons, it is going to be 96,485 times it with 2. That comes out to be 192,970 coulomb per mole. So in order to calculate the mole of copper, what we can do, 4500 coulomb divided by 192,970 coulomb per mole, and when mole will go at the top, it would become 0.0233 mole. And for finding the mass is equal to mole times mr. Mole is 0.0233, mr is going to be 63.55, and the answer comes out to be 1.48 gram. So our answer is C. Which of the following best explain why the reaction occurs at the significant rate only when the temperature of the reaction mixture is below 150 degrees Celsius? So they are saying when the reaction is feasible at below 150 degrees Celsius. So which explains that? If you see option D, like delta G is equal to delta H minus T delta S. And option D is saying the Gibbs free energy change becomes positive at temperature above 150. This option is going to be right. Why? Because above 150 it becomes positive. That means the reaction is not favorable above 150. But below 150 the reaction is feasible, and when it is like this, when delta H is negative and when T delta S is also negative, so negative becomes positive, and when the temperature increases in this condition, when temperature increase when it goes above 150 degrees Celsius, the delta G here would become positive. Why it becomes positive? Because this value will overcome this negative value, because this value becomes positive, and when it overcomes this negative value, delta G becomes positive and the reaction is not favorable. But when the temperature here is smaller than 150, delta G remains negative. Okay, delta G remains negative because this value is very smaller. It will not overcome this value. So answer is going to be D. So let's move towards the next question. Question number 39. When a chemical reaction reach equilibrium, which of the following can be said about the concentration of substance present and the rate of reaction? So for the chemical equilibrium, there are certain conditions that first of all, the reaction must need to be placed in a closed system. In a closed system, first of all, this is a condition. And the second condition is that the rate of forward reaction becomes equal to rate of backward reaction. And also there are certain condition is that the change in concentration of reactant and product becomes zero, and product becomes zero. So if we see option B, that is suggesting us the right thing. The concentration of reactant product remains constant and the rate of forward and reverse reactions remains the same. For the next question, they are saying which of the following metals would have the highest melting point. So one thing for the highest melting point, for the metals, the melting point depends upon two things. The first is size of ion. So if you have smaller size of ion, that would cause the metallic bond to be more stronger. Okay, that means stronger metallic bond and higher melting point. First thing. Second condition is, this is first condition. Second condition is that you must need to have the greater charge. So the greater the charge, greater will be the stronger will be the metallic bond. Stronger metallic bond, and we are going to have higher melting point. So sodium is having +1 charge, magnesium is having +2 charge, and aluminium is having +3 charge. Potassium is having 1 charge. So that's why our answer is going to be C, aluminium. Why it is having +3 charge? It belongs from group 3 and having the strongest metallic bond. Moving towards question number 41, isooctane shown below can be added to fuels for improved performance. So first we need to identify where the carbon is present and where the hydrogen is present. As you can see, there is a junction. At this junction there is only carbon present there, and at the corners it is going to be CH3. Here it is also CH3. Here it is also CH3. At this junction we are having like two connecting points. So for two connecting points, as you know, carbon can make maximum 4 bonds. So this is going to be CH2 because one is going there, one is going there. And this point, as it is having 3 points, so it is going to be CH because carbon can make 4 bonds, 1 with hydrogen and 3 with this other carbons. Now here it is also going to be CH3, here it is also going to be CH3. At corners it is always going to be CH3. In total, how many carbon becomes? It becomes 8 if you count, and hydrogen becomes 18. And when it burns in the presence of oxygen, and it is going to form CO2 plus water. In this type of equation, first we need to balance carbon dioxide, then we are going to balance water, and then we are going to balance oxygen. For carbon, it has 8 carbon, so I am going to put 8 here. It has 18 hydrogen, so I am going to put 9 here. So 16 oxygen here, 9 oxygen here, so total oxygen becomes 25, and here we need to put 12.5 in order to balance it, so answer is going to be B. So for the next question, they are saying 4 pure dyes A through D are spotted on the chromatography paper as indicated in the diagram below. An unknown dye X is spotted on a separate piece of chromatography paper. Both papers are then traveled in the chromatography chamber. The developed chromatogram are shown above. So based on the result, which one is going to be dye X? So if you see dye X has traveled this much distance, and if you see point B, it has almost traveled the same distance as dye X. So dye X is going to be B because it has traveled almost the same distance as X. So the best option is going to be dye B. So for question number 43, the acid base indicator bromophenol blue changes color from yellow to blue over a pH range of 3.0 to 4.6. Which statement is correct? The pK is between 3 and 6. First, let's see statement 1. For statement 1, we must know one thing, that color change occurs roughly at pKa plus minus 1. So pKa value is going to be approximately in the middle of their range, that is 3 plus 4.6 divided by 2. It should be in the middle, so that is 3.8. So in the first option they are saying pK is between 3 and 4.6, so this option is correct. For the second option, they are saying in a neutral solution, this HLN is greater than Ln minus. So one thing, when we have neutral solution, let's see option 2. When we have neutral solution, we know that pH is equal to 7. That means pH is much higher. That means pH is much higher than pKa, which is 3.8. So what happens? Equilibrium shift towards Ln minus. Okay, so here Ln minus is much greater than HLN. That means this option is wrong because they were saying HLN is greater than HILN. So now it is a suitable indicator for a strong acid weak base titration. So let's see option 3 here. So option 3 they are saying for strong acid and weak base titration. For this equivalence point for strong acid plus weak base should be below, that should be below 7, and indicator range is 3 to 4.6, which is too low. So color change happens before equivalence point. Color change that would happen before equivalence point. So it is suitable for a strong acid weak base titration, so the answer is wrong. So only option A is correct. And one thing which we have done wrong here, this third option is basically correct because they are saying equivalence point for strong acid and weak base is below 7. So indicator range is falls between 3 to 4.6, and color change happens before equivalence point. So this third option is correct. So answer is going to be B. This is going to be right answer. So next question, they are saying 44th, which of the following diagram represent a heterogeneous mixture? So for the heterogeneous mixture, we need to see one thing, that the components in heterogeneous mixture, components are not uniform, in composition. They are not uniform in composition. So you can say, like, they are basically, you can say the option A, in which components are not uniformly mixed, they are not evenly distributed. So they are not evenly distributed. So you can see that option A is going to be the right one. All other options, you can see that it doesn't show that, like here the particles are uniformly mixed, so it is going to be homogeneous mixture, and it is also going to be homogeneous mixture as well, and this also represents the homogeneous mixture. But here you can see the one type of particles are on one side and other type of particles are on other side, so they are not uniformly mixed. For question number 45, they are saying K2 potassium hydrogen phosphate has the formula K2HPO4. What is the conjugate base of this compound? So when it donates a proton, it becomes K2HPO4, and when it donates a proton, it becomes K2PO4 minus plus H positive. So you can see this was an acid, and when it donates a proton, it becomes conjugate base. And K2PO4 minus, it forms 2K positive plus phosphate ion PO4 minus 3. So basically this phosphate ion is a conjugate base because K positive is a spectator ion, that is a conjugate base, and this act as a spectator ion. So our answer is going to be C. So for the next question, which is question number 46, reaction 1, HNO3 plus ammonia that reacts to form ammonium nitrate. We have to identify which reaction is enthalpy of combustion, enthalpy of formation, enthalpy of neutralization, and enthalpy of reaction. So first of all, if you are going to see reaction 1, reaction 1 is in which an acid reacts with base to form a salt. So that is going to be enthalpy of neutralization, in which an acid and base reacts to form salt. Then we have decomposition reaction. Decomposition reaction is going to be enthalpy of reaction. Then you can see this is forming SO2, and when you are forming SO2, when sulfur reacts with oxygen and form SO2, means sulfur is burning in the presence of oxygen, so that is going to be enthalpy of combustion. And if you see all of the reaction, all of the reaction are enthalpy of reactions as well, and this one is also enthalpy of formation as well. Why enthalpy of formation? Because 1 mole of a compound, you can see enthalpy of formation is what? When 1 mole of compound is formed from its elements, So that is also an example of enthalpy of formation reaction 3. Now let's see what is going to be our answer. So if we see enthalpy of combustion, that is specifically reaction 3, so it could be B or it could be C. Then if we see enthalpy of formation, that is specifically reaction 2. And if we see enthalpy of neutralization, that is 1, and enthalpy of reaction could be anyone, so we can choose reaction 2 for that as well specifically. So we can see the option B is going to be the right one. For the next question, they are saying which mass of carbon and hydrogen respectively would be the same as the mass of carbon and hydrogen in pure sample of butene. So first of all, it is the molecular formula, and if you want to find its empirical formula, that is going to be CH2. And when you see option D, let's find out for option D. Let's find the empirical formula for that. Carbon and hydrogen, we have 72, we have 12. First we are going to find the moles, so I'm going to divide with the molar mass, that is 12.01, and for hydrogen that is 1.008. Answer comes out to be 6 ratio 11.9. so dividing with the least value, that is 6, so 1 ratio 2 comes. So answer is going to be D, because for this option we are getting the empirical formula, that is CH2, because carbon is in 1 and hydrogen is having the ratio of 2, so that is CH2, which is the empirical formula of this compound. So for the next question, they are saying we have like 2NO2 which is forming 2N2 and O2. So basically what is happening, 2 moles are forming 3 moles. They are saying the reaction is completed at a constant temperature 800 Kelvin in a regular rigid vessel. The N2O is initially present in the vessel at 1.50. so initially the partial pressure is 1.50, because this is N2O and this is for N2 plus O2. Initially there were 2 moles and then they are forming 3 moles. So they are saying initial pressure of N2O is 1.5 atm, so 1.5 I'm going to write here. They are saying what is going to be the final pressure for N2 and O2, so that is going to be X. Just cross multiply them, you are going to have 2X is equal to 4.5, and X comes out to be 4.5 divided by 2, and answer is 2.25. so answer is C. For question number 49, if the pressure of SO3 was 0.063, what is the concentration of O2 in equilibrium? Okay, this should be the concentration. This should be the not the pressure, that should be the concentration. So for that purpose we need to use ice method. So this is 2SO3 and is forming 2SO2 plus O2. So first we have initial, change and equilibrium. Initial is going to be for SO3 is 0.06, that is 0 initially. And change, if you are asking about change, then here it is going to be, as there are 2 moles, so I'm going to put minus 2x, and that is 2 moles, so I'm going to put plus 2x, and that is x as well. So for equilibrium that becomes 0.06 minus 2x, and that is 2x, and that is going to be x. So Kc is equal to partial pressure of SO2, like product side, and that would be square at top, and that is O2, and at bottom is going to be SO3 whole square. So Kc here is going to be value of Kc. We are putting the value of Kc, then putting the value of Kc here, and the remaining value Kc is 1.7 times 10 to the power minus 18. SO2 is 2x whole square, and O2 is going to be only x, and at bottom is going to be 0.06 minus 2x. As the value of x is very small, so we can put x equal to 0 at bottom. So this one would become 1.7 times 10 to the power minus 18 is equal to 4x cube over 0.06. 4x cube comes out to be 6.12 times 10 to the power minus 21. X cube comes out to be 1.53 times 10 to the power minus 21, taking cube root on both sides, and the answer comes out to be 1.15 times 10 to the power minus 7. So the answer is going to be C. Then we are going to have the Arrhenius equation, k is equal to a e raised to power minus ea over rt. They are saying what does the value a actually represent. So the factor a actually represent two things. First, let me write them. So the value of q, that basically represent two things. So two things are going to be p is the steric factor, which shows the fraction of correctly oriented collision that results in reaction, and c is the number of collisions per unit time. So we are going to have the right answer, that is going to be B. B is going to be the right answer. It accounts for the total number of molecular collisions and the fractions of correctly oriented collision that result in a reaction. So the right answer is going to be B. So for question number 51, now we have a lattice structure, and if you see this lattice structure, that represents an ionic compound. So if you see here that each is surrounded by same number of ions, and first of all we come to know that ions, they are going to have 1:1, because if you see structure, then they are going to be same positive ions and negative ion. Each is representing a positive ion, like maybe this is representing a positive ion and this is representing a negative ion. So we are having the same number of positive ion and negative ions. So first of all, they are in 1:1, so this option is going to be cancelled out. Now for the next part, they are saying like the force of attraction between the ions is this much. Use the information to determine the identity of the substance. So formula for force of attraction between ionic compound is F is equal to K Q1 Q2 divided by R square. So K is a constant which has the value of 8.98 times 10 to the power 9. So let's see the value of Q1 Q2. So if it is going to be NaCl, the value of Q1 and Q2 is going to be -1, because Na is having +1 and chloride is having -1. For calcium and oxygen, it is going to be +2 and -2. For aluminium and nitrogen, it is going to be +3 and -3. So for if you are putting here the value of calcium oxide, that is -2, like +2 and -2 for Q1 and Q2, and for R square, which is we are having 0.412 nanometer, we have to convert it into meter. That comes out to be 10 raised to power -9. 0.412 times 10 to the power -9. Then we are getting the right answer, which is going to be -8.46 times 10 to the power 29. So our right option is going to be calcium oxide. By putting the value of -2 and +2 as their charges, we are getting this answer. So right answer is B. So for the next part now, for question number 52, they have given us the concentration of hydroxide ion. So concentration of hydroxide ion that is given to us is going to be 0.001. And first we have a formula, Kw is equal to concentration of hydrogen ion times with the concentration of hydroxide ions. So that is Kw value is 1 times 10 to the power minus 14, and hydrogen ion concentration we need to find out, and for hydroxide ion it is going to be 0.001. Now finding hydrogen ion, what we are going to do, 1 times 10 to the power minus 13, minus 14 divided by 0.001. Our final answer that comes out to be is 1 times that comes out to be is 1 times 10 to the power minus 11, and we know pH is equal to negative log of hydrogen ion concentration, and it is minus log of 1 times 10 to the power minus 11. So answer that comes out to be is 11. So answer is C. Which statement is true about metallic solids? For metallic solids we have like cations which are surrounded by delocalized electron, and there is a force of attraction between them, that is electrostatic force of attraction, or we can also call it as Coulombic force of attraction. So answer is C. Like metals are held together by Coulombic force of attraction between positive ions and delocalized electrons. Then which statement about buffer solution is not correct? First, we have a definition of buffer solution, that buffer solution resists the small change in pH when a small amount of acid and base is added. So first let's see D option. When a strong acid is added to a buffer, hydrogen ion reacts with salt ions. That is absolutely correct. The pH during a titration between a strong acid and weak base changes slowly in the buffer region. That is also right. A buffer can be found when sodium hydroxide are reacting with a weak acid, that is ethanoic acid. That is also correct. But this statement is incomplete, which says that a buffer resists small change in pH when a small amount of acid or base is added. So this is incomplete, so we can say that this is wrong. For the next question, we have question number 55. The structure of glycine is shown above. What is the correct number of sp2 and sp3 atoms in glycine? First, if we see carbon is S, sp and sp2. So this carbon is going to be sp2 hybridized. Then if we see this oxygen, this is having a lone pair on it. So this is S, sp and sp2. So this is also sp2 hybridized. Now if we see this nitrogen, this is having a lone pair on it as well. So this is S, this is sp, sp2 and sp3. So this nitrogen is sp3 hybridized. And now if we see this carbon, this is being bonded with 4 other carbons, so this is going to be sp3 hybridized. Now if we see this oxygen, which is having the lone pair here and one bond with hydrogen, so total pairs are 4, so that is also sp3 hybridized. So how many sp3 are there? 1, 2 and 3. And how many sp2 are there? 1, 2. So 2 sp2 and 3 sp3. So answer is going to be C. Now for the next question, consider the following reaction at different temperature. The equilibrium constant K values are measured at each temperature. So they are saying which of the following correctly ranks the amount of product in the equilibrium mixture. So if we have greater the value of Kc, greater the value of Kc, greater the product, greater product will be there. So we need to see where we are going to have the greater Kc value. So first of all, the least value is going to be at T1, T1 is going to have least value where Kc value is 0.001. It is 0.01. And for T2, let's find it for the next biggest value, that is going to be 1 definitely. So that is T3, and that is going to be a value of 1. Then we are having T2, which is having the value of 10. Then we are having T4, which are going to have the value of 100. So T1 is the smallest, T4 is the biggest. So the right option is going to be D. So for the next question, they are saying which of the following statement explain why substitutional alloys like brass are malleable. First of all, let me write some facts related to substitutional alloy. So these are the facts in which they are saying that in substitutional alloy, it replaces atom of original atom with another which has the same size. Second thing, the sea of delocalized electron in metallic bonding is not affected. Layers of atom can continue to slide past, which makes them even malleable. So the right answer is going to be D, that substituting atom maintains the metallic bonding sea of electrons. Then 58th question, what is the standard Gibbs free energy for the reaction for the above reaction at 25 degrees Celsius given the standard cell potential is 1.10 volts? So we have to find Gibbs free energy, which is equal to minus NF E naught. Minus N is the number of electrons, like zinc loses 2 electrons and copper gains 2 electrons, so we are going to put 2 here. Faraday's constant is 96,500 and E naught value is 1.10. So the answer that comes out to be is minus 212,267 joules per mole. And when we are going to convert it into kilojoules, so that one comes out to be minus 212.267 kilojoules per mole, and the answer is going to be B. Which of the following best describe the changes that take place immediately after liquid ethanol is introduced into a previously evacuated vessel? So first of all, when it is introduced in a previously evacuated vessel, then C2H5OH generally vaporize and would be converted into C2H5OH in gaseous form. This was in liquid form, and that generally turns into gaseous form because here we are having no external pressure. So it generally changes into vapor form. And then what happens, as this is a physical change, where a liquid is changing into gas, no other compound or thing has been formed. So that's a physical change, and that requires energy to overcome, that require energy as well to overcome intermolecular attraction. So our right answer is going to be D. Then moving towards the last question, they are saying about interstitial alloy has different properties to pure iron. Like interstitial alloy, which is steel, has different properties to pure iron. For steel, you must need to know one thing, like carbon is added into iron. Okay, so what happen in them, that smaller atom which is carbon fill the gaps in larger atom which is Fe, and what does it do? It increase the strength and alter the mechanical properties, like providing it more strength as well. So right option is going to be C, that carbon atoms occupy the space between iron atom and strengthening the lattice structure.